Most of the models suffer from a problem called overfitting. Overfitting is the result of putting too much hard work into building a model and reducing the error rate or increasing the accuracy. So what is the problem of overfitting? So in search of the best model on the given training data, we add as many predictors as possible. We add so many interaction terms, transformations, derived variables, indicator variables, dummy variables. We do so many things just to reduce the error, and every time the error on the training data is reduced, we feel so happy, and we go ahead, try to do or include many more variables. So we try to complicate the model, or we generally complicate the model by knowingly or unknowingly, and finally end up with a model which is very complicated, very complex, but still the error in that model is less. By error we meant to say the training error is less. So most of the times we do succeed in reducing the training error. So once the training error is reduced, in fact if we do enough or if we add enough complications, we can even reduce the training error to 0. But is that the best model? What about the test data? Did we do test error? I mean, while building the model, if we are not taking care of the, or if we are not at all looking at the test error, then we might end up with a problem called overfitting. So imagine there is a training data. I take 3 random samples, sample 1, sample 2, sample 3. If I build a model on sample 1, M1, then I got few parameters, or I got a result few parameters, theta 1, theta 2, theta 3. And if I build a model on sample 2, the parameter or the result should be similar to that of on sample 1, because these two are random sample. Both of them are true representative of the population, that is training data set. The model should not really change. But if we are putting a lot of effort to reduce the error in model 2, then the parameters might be different, and we tend to fit the best model that will suit just for that particular sample that we have chosen. So the model is just really best for sample 1, M1. So M2 is maybe M2 might do really good only on sample 2. It is just a perfect fit for sample 2. M3 might be just a simple perfect fit for sample 3. So this phenomenon is called overfitting. The model is the model is made really complicated. In fact, the model is very sensitive to minimal changes in the data set. Even if we change simple values, the whole model might get really changed. So the model is really complicated. There are so many parameters in the model, but the training error is near to 0. So that is the problem of overfitting. So the model tries to fit irrelevant characteristics in the data, because there is no real generic trend, but still the model will try to fit a model for fit and find out that pattern also, because we want the error to be really near to 0. There might be certain amount of accuracy that is present in the data or the model. We still want to push it further and even increase the accuracy, reduce the error, then the model tend to overfit. So generally overfit model is really good on training data, but when you look at the test error, it will fail. So it is not so good on test data. So if a model is really working well on your training data and it is not working well on your test data, then that is called overfitting. We fit the model for the noise in the data. So there is some randomness in the data. We did so many things, we complicated the model so much that we even fit that noise in the data. So the less training error, 0 training error, high testing error is a phenomenon of overfitting. The model is over complicated with too many predictor variables. The model need to be simplified. It's okay to increase the error. So these are the models with lot of variance. They are perfectly fit for the sample data that is there in our hand. If we change the data slightly, then the model changes hugely. So these are the models with over these are the overfit models, and they have lot of variance. Let us see some of the models with huge variance. Now let us see an example of overfitted model, or the model with the huge variance. To see this example, we will take the fiber bits data, we divide it into two parts. So the overall dimensions of fiber bits data is there are 9 variables and 100,000 observations. So we will take first 90,000 observations, consider them as training data, and take remaining 10,000 observations from 90,000 to 100,000. 10,000 observations considered as test population or test data set. Now on the training data set, I will build the best model, or let's build the best model that we can. So on the training data set, I have chosen the control parameters in such a way that I'll get the best model on the training data with the least amount of error, that is the highest accuracy. So we are expecting an accuracy of near 100% or 95% is the accuracy on the training data. Now is this the best model? Is this the model that we need to settle down? Is this the final accuracy of our model? May not be. Let us check that on the test data. So we are using the same model, but this time we are predicting it on validation data, fiber bits validation data. So we are predicting it, and we are creating a confusion matrix on validation data. So here is the confusion matrix on the validation data set. Looks like not a real good accuracy, but let's find out the accuracy on the validation or the test data. Accuracy is 71%. On the training data, the accuracy is 95%. On the test data, the accuracy is just 75%. This is a typical example of overfitting. We will overfit the model just for training data. So it is a very good model just for training data when you have some unknown data, when you have some different data set which is similar but with different values. Because of those simple value changes, okay, the whole model, the variance of the model is so high that the whole model tend to fail on the test data. This is called overfitting. A model is just good on training data, not so good on test data. We have seen the problem of overfitting. That means when we overcomplicated the model with too many variables, then we might end up with good training error, but testing error is really high. Now having a simple model is always the solution? May not be. If the model is oversimplified, then we might not be capturing all the data. If we really require 20 variables and we are using only 10 variables, then we might lose out on the real good information that is there in the data set itself. If we don't do enough research and feature re-engineering, then how can we fit the best model on the data set that is given to us? First of all, if the training error in itself is really high, if the model is really simple, then the training error itself is really high, then test error will be anyway high. In fact, the model need to be complicated enough to capture all the information that is present. We can't oversimplify the model. So by oversimplifying the model, if we are losing the information, that is called the problem of underfitting. We are not utilizing the overall data. We are underutilizing the overall data set and the patterns within that data, or the information in that data set. If the most of the accuracy, in fact, for measuring the training data, we have many accuracy measures, in fact, or error measures, something like confusion matrix or accuracy, everything, the first thing that we measure is on training data. So as soon as we see a training error something like 30% or 40% accuracy of just 60%, we already know that the model is not a really good one. So if the model is too simple, and if the model has a scope to improve, then that is called underfitted model. That model has already bias in itself. It is not really hitting the target. It is already away from the uh, final target variable that we are trying to predict. It has a lot to do within the model. We need to do some more research and add some more variables, try to increase the accuracy. So oversimplification is not the solution, and if we did not do enough research, then the model is not good in the first place itself. That is called underfitting. We might have to add some more variables to increase the accuracy. So these are the models with bias. Overfitted models are with models with variance. Let us see an example of model with huge bias. That means a oversimplified model that is already underfitted. That is um, basically we mean to say that there is not much, or we are not using already present information within the data set.